Hello guys, welcome back to my channel. Let's solve today's POTD. So now let's come on to the question. This is my solution. So in the question we are given in square grid. So grid is of size n cross n and each cell contains some value. Okay. So we have to move from starting point to ending point. Like this is the grid. So we have to move this point to this ending point such that we get the minimum cost. These are the costs, so we have to choose the path such that we get the minimum cost. And how we can move from any point, we can move in all four direction this way. Suppose if you are here, you can move this and this. Diagonal are not allowed, diagonal moves are not allowed. See, this is the given condition. So let's understand how to solve, like how to approach these kind of problems. So I'm taking the input here. So first thing is, let me create one 4 cross 4 grid. Okay, so first we need to understand this question is of which topic, like what is the topic of this question. So this is 9 4, again 9 9. If you know the topic, it is very simple. Otherwise you will stuck in the question and you will try every random approach like greedy, ndp, all these things. This is important thing is this is not dp question. And how will you know this is not dp question? Because most of the questions like minimum cost and that are related to dp, but this is not dp because in dp type kind of question we can move only right side and down side. This is the key thing, like you can say. Otherwise how will you know? If there is any directed acyclic graph, then only you can apply dp. Okay, otherwise you cannot apply dp, then only dp. Here suppose we have started from here, we can go this side, they go this side, go this side, we can come on the same node again and again. It is not dp, it is not dag, but like so this is not dag, so this is not dp question. Let's say problem are like only right side and down side, then graph will something look like this. There will be no dag, there will be dag like directed acyclic graph, there will be no cycle. So here we can apply dp. So important lesson, dp only if dag. If dag is we are getting dag, then we can apply dp. Okay, so this is the key lesson you can understand from this session. And what is the other things? Okay, now, so as you can see, like if it is not deep question, simply it is a graph question. From like we can make the graph like edges from here to here, and then we can say like this one, this one is, this is one is, this is one is, like we are moving from this way. Okay, so these are the edges of graph. You can, if you're not getting how this is graphs, so this way we can say these are graph and these all are node. So we have to move from this node to this node, getting the minimum cost. Okay, so in there are weights, so like these are not unweighted. So for weighted graph, for weighted graph and finding minimum cost or minimum distance, anything, finding minimum cost, yeah, distance. Which algorithm we use? We use Dijkstra. Okay. We use Dijkstra algorithm. In Dijkstra algorithm, this is the, let me show the original Dijkstra. In original Dijkstra, we are given some nodes, like we are given some graph, let's say G, and G of I will tell, G of I is a vector that contains neighbor of I, any neighbor of I. So these are processing, the processing part of graph. I'm not going into that stuff. Suppose 1, 2, 3, 5, 6. These are node numbers and these are the edge weighted, edge weight. So in this question, like in this type of question, we are given like starting node starting node given and ending node given, and we have to find the minimum cost to reach from starting node to ending node. So if you see something like that, then you can apply Dijkstra algorithm. In this type of question, what you do, we maintain the priority queue, and we in priority queue we push distance and node, and we will sort according to distance. Means shortest distance. Oh yeah, फिर otherwise the shortest cost first, the minimum cost first. If you are looking in the you're looking for cost, so then it will be minimum cost. So like let's say our starting point is this. I'm explaining the complete approach, and ending point is, let's say, this. And there are some other edges also, like here also, let's say some 20, then okay, 20, 10, no 10, no, 28 and 1. So how will you know which path is more? So it is obvious that now I'm creating a cost array where you can say I'm distance array. So distance of s starting point will be obviously will be 0 from starting point. Okay. So what I will push distance is 0 and starting point. So from here what we can say, like this is in the priority queue, we will take out the uppermost value, so which will contain the minimum distance. Like if we are here, from what we can say, if we are here, there are three edges, 1, 2, 3. So we can say we can definitely reach here with here zeros, then we can definitely reach here in 7, 10 and 20. We can reach definitely in 7, 10 or 20 cost, we can definitely reach, right? But this is the minimum. Okay, so we are get this, like we set it as weight, like minimum distance is 7, 10 and this is this, and now we will push push this value, push this values. How what we will push? We will push 7 and node number is 3, and here 10 and node number is 1, 10 here node number is 1, and 20 node number is 4. So p in priority queue, how will this will appear? This will appear in the same way, because according to first value we have to sort. Priority queue in general, original priority queue gives highest value on top, but I will make the priority queue according priority mean heap I will make, so lowest value will come first. So say this will come first. Now here we are, and now we mark this as wasted. Now from here what we can say? We can say like with 7 distance, we have 7 cost we have already occurred. So 7 plus 40, from in 47 distance we can reach to this node. We can say or not. Okay, we can say this thing, and this is the minimum, because here it is a minimum, because we are starting from minimum cost. Minimum cost is starting point, cost is minimum cost. So if we started from here and there is 7 cost is there, so this is the minimum, and there is one path of 47. Okay, so we will save this as a 47. Okay, and there are no other edges, because we have already marked this as wasted. We have wasted this node, so there is no neighbor left. So we have done everything about this, and now we will push this node. How will push node? We will push 47 and 5, but there will no neighbor, so I don't think we will do anything of that. Now let's come to the 10 1. Where is 10? Here it is 10 and 1. So here it's cost is 10 and no neighbor is there. So mark this as wasted. Like we have done everything of this node. We have done. Now for 24. Here 20 and 4. There are 3 neighbors of this. 1, 2 and 3 neighbors of it. What I will do? I will push all these neighbors. Like now in your priority queue, what is there? 47 is 4. Sorry. 47 and 5 is there, this 47 and 5. Now we are at here, so we will push 20 20 plus this 30, 50, and node number is 6. And for this one, node number is 7. This node 20 plus 8, this is 8. 20 plus 8, 28, and node number is 7. Now, so which is the minimum? This is the minimum. Node number 7 has the minimum distance. So we will come to this node first. We have done of this work of this node, this node, and this node. If we have pushed all number of any node, then that means mark this as visited. I will show how to do these things in code. Now let's, which has the minimum distance? This has the minimum distance. So now come on this node. So now we are at node, this node. So now what I will do, I will mark this 28 and 1, 29 and 9, 29 and distance 29 and node number 6. Now what you can say, there are two things. No, we have the same node but different values. Now this we will mark this as 29. Initially we have marked this as 50, but now 29 is lesser than 50, so we will mark this as 29. And there is other node, this node is wasted, so everything is done of this node. Okay, now what are the things left in the node? This is wasted. So now these 1, 2, 3, these are left, so I will take on the 19 and 6. This node is wasted. Now if I am at this node, important thing, this is not wasted, not wasted, not wasted, not wasted. Wasted means we have we have pushed the whole node of that node, push the whole neighbors of that node. Now at we are at, which is the minimum? This is the minimum. 29 and 6. Here is the, here we are. Okay. So from here we have neighbor this one and this one. This one we have already processed. So this is done. This is the node left. So what is the distance if we move from this to this? 29 plus 30 means 59. So when we will push, if the current distance like 59, we are getting this way 15, and okay, sorry, we have already accessed we have already processed this node. Why we are not, we will not check process node again, because we are following the shortest fast first. So if we are getting some node in shortest fast and we are doing anything and then again come to that node, it is not, definitely not give the shortest value. Okay, in first time we will get shortest value. So in here we have sorted all this neighbor. So work this out, and they are 56 and 6. Work this out same, because, and 47 and 5, 47 and no number 5 somewhere here. We have no neighbor left. So this is the minimum cost. Here you will see 10 correct, 7 correct, 47 correct, 20 here, 20 plus 30, 50, and here 50, and then again after some time we get 29. The minimum will be, we will keep the minimum, so it is 29. If you go check, like there is two part, 20 and 50, 20 and 30, 50, and 28 and 1, 29. So 29 path is the best path. So this way things works. Now let me show you the Dijkstra code and how this, in this question what we will do, instead of pushing starting distance 0, we will push starting distance as 9, because here starting point is 9, and node here, node will be pair, or node will be pair like I and j, so 0 comma 0. So this thing I will push in the priority queue. And same thing, we are not, how will we know the neighbor? We will add +1 and he will access in all 4 direction. So we will get the neighbor, like if we are here, so we will add, we will process in all these 4 are neighbors of this one. Okay, and as weight we are considering 4, like if we are at here at 0, 0, here we are at 6 cost, so reaching here, how much extra cost it will take? 4 now. So this we can assume, like this edge have a weight of 4. So this way we can do. So I will create one another separate video for Dijkstra and graph algorithms. So let's understand today the question, how I solved the question. So now I am explaining the question correctly. I have written code very clean and neat and clean, and it is very important to understand. Like it is very important. Okay, what it is saying. Can I paste somewhere? Okay, sorry guys, I'm little bit new to this technology, so I'm like I'm making copy paste till while I'm okay. So I will this way. Okay, this is fine. What's what happening here? Yes, I will add the I will add whole code in comment section, so don't worry about that. Okay, no, it's fine. Okay, so here I have written. So y dx and dy. Suppose we are at this node. So we can how we will move these are four direction. To move it efficiently, I have created directional array like dx and dy. These direction array I have created. Suppose you are at 4 comma 5. So if we are four possible ways, na 4 comma 5 to this way. So if you will 1 and 0, then you will move to 5 comma 5. If you add minus 1 and 0, you will move to 3 comma 5. Same way you will like if you are writing this way, you will efficiently move the you can access the all four direction this way I have done later. So this direction area I have maintained, you should maintain this. And distance area initially all distance is 1 in 9 because we want to minimize that. So initially it is better to keep them as maximum, and we not wasted any array any node, so it is 0. We have node I comma j. It is not say single node. This I comma j is node, okay, because we I comma j will give the complete information in grid. So we have maintained priority queue, distance, and pair I comma j here. So pair, and I this is the pair I have defined here in the code. So I have, as I said, we want minimum distance element on the top of priority queue. So I have pushed the negative, and while I will take out, I will also take out as negative. So this way I will get the minimum element on the top of priority queue. So I am pushing distance and node. Here starting point is 0, 0. So this is node and this is a distance. And now while priority queue is not empty, we will take out the topmost element, remove this from priority queue, and this is a distance of that node, uppermost node, the top node you can say, and this is the indexes, like this is the node, you can say now this is the node, and this is the distance, like this here. Here we are doing like this is the node and this is the distance. So this is the node and this is the distance. If node is visited, then you will continue, we will not do anything. If it's not visited, because we are going now, we are going to push all these neighbors into a priority queue, so we will mark it as visited one. Now for 1k equal to 0 to 4 means we will going to process in all far direction. Suppose we are here in first time we are k for k equal to 0. Suppose we are getting this node. So this is the next I and next j, current and next. So next I and next j is the coordinate of this node, next node, like after adding. So if it is inside, it is not necessary to check like if you are at here and you are at any, so you can go this side also, na. So first check whether it is inside the grid or not. So if it is inside the grid, I have written here check. Okay. So this is a simple check you can understand. So if it is inside the node and distance of node is greater than distance of node, so okay. So as I have mentioned here, okay, like here, what I said, like if you are here, node, current node, and this is the next node, next. So this three will consider as a weight, right? So For current we have distance or cost. For current we have, this is the current, this is the weight. For we are moving to the, what will be the weight? Weight will be the grid of next I, next j, and we are reaching to which node? We are reaching to next I, and next j we are not reaching to. So we will check if the already existing distance is higher than this distance plus this, then we will minimize the distance. Otherwise, if it is already like it's a 9 and this weight is like let's say 4, and we are reaching somewhere from 10, 10 plus 4 14, so it is not anything like, it is not good to move from this path, because they some in other path in if you in like you can say from any other path we definitely definitely reach at here using 9 cost. So it is not good to follow this path 10 plus already reaching same node at higher distance. So if we are reaching at lowest distance, like this is the current, this is the path distance, no? Distance, current distance, distance of node, and distance the, this is the weight of edge, you can say. If this is less than a current already existing distance, then it is better to follow this path. Otherwise, if it is not less than, then why we should follow this? So this, and so if is this, so we will rest the edge, like we will up we will change this to minimum. And now what we will do, we will again push the next node. How we will push? This is the distance of next node, I we know, so we will negative, push the negative to maintain the priority property of priority and coordinates. So this way this loop will run, and we will get the minimum distance of distance n minus 1 n minus 1 way. I have added the code in the comment section. I think video काफी लंबा हो गया है guys. So let's stop here, and you can check out the code in comment section. If you have any doubt, then you can ask me in comment section, or if you want a complete video on Dijkstra, please comment. Thank you guys, and follow, like and subscribe.